Hello, everyone. Welcome to the session. Today, I'm here with Kseniia. We met some time back. We interacted over LinkedIn. Kseniia has been, making a lot of videos on her YouTube channel as well. I'll let her introduce what she's doing. In this session, we will talk about Cassandra and few more things, but we will understand as we move ahead. I will hand it over to Kseniia now.
Hello, everyone, and thank you for watching this recording. We're really happy that you make your own time to watch this video and get yourself educated about the power of Cassandra. And for the sake of this video, what we're going to do is discover what is Cassandra as an open source and how to use it. And as we're starting, let me introduce myself. My name is Kseniia, and here's a little bit of background, who I am and where I'm coming from. As today, I'm solutions engineer or data architect, what I'm being called at DataStax company, where I'm being today. And a little bit of a background from me. I'm originally from Russia. And a fun fact, my hometown, Vladivostok, is being located on the most east side of Russia, next to Japan. And that city is being called as Asian Gate. Why? If you look at this picture, you might understand, because Vladivostok, as the Russian city, is located next to the Korea, Mongolia, Japan, and historically it's been known as a really strategic place for the military bases. Once I came to United States, I have opportunity to go to UC Berkeley and study computer science. That was a point when I get into the tech world. And after that, graduating after 2017, I get into the blockchain space, and I was writing smart contracts for the company called IOLite, who was building the engine to make smart contracts easier to use, such as brings this gap between the developers and the businesses who need to use smart contracts day to day. Later, I joined Oracle, where I was a part of application integration team. That was a point when I learned and practiced more APIs and application connections. Right after, and for the last 2.5 years or so, I was part of HashiCorp. And at that point, I was helping enterprises to innovate the CI/CD pipelines. I helped them to bring the initiative to automate the infrastructure. And today I'm being part of the DataStax, which I've been serving for the last 3 or 4 months. So here's a little bit of my background story.
Good.
And as what you heard recently, agenda for today, we're going to start with a little bit of database history. Why? You've seen this name as Cassandra, and for some of you, that name does not really mean anything. So we'll start from the point discussing what's relational databases, what NoSQL databases. Then we'll step into Cassandra world and overview all the power, what it takes, and some trade-off, because there is no single one solution in tech that can resolve everything and be the perfect fit for everything. So there is certain aspects that Cassandra is good for, and certain aspects that relational databases are perfect for. So we'll discover both of these type of worlds. Then we'll step into what DataStax and what it provides, and we'll leave some time for Q&A. Sounds good?
Sure. Yep.
So looking at this image, and some of you might have seen this analogy of iceberg, and what usually iceberg analogy brings is there's always something on the top, and something on the top is usually being perceived as not more than 10%. And what you see here at the top of the iceberg, all this needs what all enterprises are striving for, and what they're striving for data-driven approach, for deep learning, bringing AI for what for? To understand what the end users need, how the businesses can provide more value to tailor their platform, their solution to the end users. As all of us heard of AWS power, right? If someone look at the Amazon as a company, Amazon really got successful because they've been always from the day one customer focused. And that approach being held, like what at least I observed from my point of view, that is something that holds a lot of enterprises moving forward. But the reality is, looking at this next 90%, it's really hard to get to that point. And why it's hard? Because even though today, like in 2022, we live, usually we have a lot of data points, a lot of data, like petabytes coming in. And the problem, and that is a real problem that a lot of enterprises facing, they have a problem with data governance and data management. And today, describing possible solution will focus on data management, how to aggregate the data and get the most out of it. And talking about the database history, some of you that somehow one way or another been interacting with relational databases, that is a typical approach. And that is well-known approach. Why? Because from even historical point of view, relational databases were established much, much earlier compared to NoSQL databases. And relational databases usually work from the pattern as we have some data being stored, usually in bulk, usually in some like data lake, data warehouses. Why? Because we have different streams and we have a pool to gather the data. Then usually what companies do, they model the data was they stored previously, and they put the tables as, let's say, give an example. Let's say we build an application that will need to use employees and which department they are. Having this model, when we map these models to the end application that will need to incorporate and pull the data in a fast result, usually a lot of real-time applications, or at least companies who strive for real-time applications, they have been faced with a lot of delays, scalability issues, and so on and so on. And one reason for that approach is gather data first, model it, and then make it real time for the end user. It doesn't work. Why? Because relational databases, they might be good, in certain time solutions, but they're not being wired for real time applications. One of the examples, or like point to bring, is joins that usually take a lot of time to bring the data together.
So I think one point which I would like to add there, one of the reasons why relational databases were designed in this way, like if you look at the time when they were developed, at that time there was a lot of stress around using the storage in the most optimum way. So one of the design methodologies, if we see when we are using relational databases, or if we are trying to design our database using any relational database like Oracle, SQL Server, etc., what would happen is that we will try to make sure that there is no duplication of data. That is something which we study as the principles, right? So for example, if you see here on the screen, we have employees and departments. We would not go ahead and put department information in the employees table itself, because there might be 10,000 employees, and that way you are repeating department information again and again, right? Instead of that, you will just put department ID there, and then at the actual time, join will happen. But then this join takes time, and we constantly kind of try to make sure that how do we make our joins more and more efficient. But ultimately, the data is spread across multiple tables. So that's the historic thing, how it used to be, right? If it helps. Yeah.
100% agree with you. And maybe as a summary to the point what you just said, that is absolutely true. Back in the day, the storage was expensive. Nowadays, when we live in 2022, the storage become really efficient and relatively cheap in price. And second thing, what you brought up, what's normally known in the database world as normalization and denormalization. So what you mentioned about normalization, when we just, in the sake to save the storage, we want to make sure there's no duplication made. And that has been usually the driver back in the day. But talking about denormalization, this is the point when, or better say, reality where we live today. And reality is the storage is not more concern, but what is concern is how we can make this data real and provide the real insights to the end user based on application the business serves. And one of the options, or maybe one of the tools, and I heard that is one of the most powerful NoSQL databases as Cassandra that can enable this architectural pattern to follow the thread, such as, let's say, imagine you're a business owner and you want to provide the real fast, real-time input and output to your application. Imagine like you come to the, let's say you just woke up in the morning from your home and you love Starbucks. So what you can open your application, pick the location when you want to pick it up, and pick the type of coffee you like, cappuccino with maybe caramel sauce on the top and so on. And then you just make a click, and you as an end user assume that your coffee is going to be ready in the time that the application provides you. Just imagine if that application have like 1 hour, 2 hour delay. That probably will be a little bit of frustration, right? Because you need to start your working day in the morning. And talking about this real-time application, that is the point when Cassandra brings its power. And looking at this pattern as the point when Cassandra brings the most value is when one who builds on Cassandra have a queries on top of mind. What does it mean? Such as before just collecting any data, there should be understanding what users need based on the queries or access of application. So once it's done, Cassandra can provide the power to create wide column distribution of the data. So, and the data in this case, what we just previously mentioned, being normalized to denormalized. In this case, we will end up having a lot of repetitive data stored in the same data model. And you might ask, like, why? And the reason for that wide columnar database or approach is being meant because we don't want to have joins. We don't want to have delegate different processing, interaction, aggregation of the data. What we want from application standpoint, have one endpoint and ability to retrieve the data from database source. And then having that structured data model, we can store it in the data. And that point is really insanely critical. If you remember this iceberg analogy, when we want to bring machine learning and analytics in the place, and the huge key point is being in real time, you want to have your data aggregated already, in a set point when your machine model or feature store can be, put in the place, and you can predict your real time to provide the value to your end user.
Right. I think that's really important. On the left side of the screen, you can see something which is very critical. Here, in this mindset, we are saying that what is our end objective? Our end objective is to make sure that user gets a good experience while using the application, right? And it is not just about on principle, as a principle, storing the data in the best format. That's not the ultimate goal. Ultimate goal is about giving that good experience to the user. And hence, if you see on the screen, as Kseniia is showing, that first you have to look at the application. You have to try and understand that what type of experience we have to give to the user. And based on that, you will actually define the different queries which your application would run. And then you will define the data model in such a way which is more suitable for those queries to run efficiently. And Cassandra helps in that direction. Yep.
And you might at that point ask a question, okay, we heard enough about what's the differences between one database and another. What is the power of Cassandra? And maybe as a summary, believe it or not, you as that end user, what we've been referring to, you've been already using Cassandra without even knowing it. So if you use iMessages from Apple, or if you ever order food from DoorDash, or maybe you've been watching Netflix movies, and Netflix, if you notice, been giving you some recommendation what next movie you might like. So all these companies that you see right now, and to that previous message that I mentioned, all these companies using Cassandra to serve the end users, to provide them the best experience what they can to drive the business innovations and income.
So that clearly shows that there is a lot of usage of Cassandra, and hence I think Cassandra's skill is going to help. learners, of course.
While Cassandra has a lot of capabilities and power to serve out of the batch, by using Cassandra, I think this is the three top definitions that can be given to Cassandra. So Cassandra is open source, which is Apache today owns the source and can be used for free without any requirements or additional cost. And by just start using Cassandra, Cassandra is a NoSQL database that will provide 100% uptime, zero lock-in, and global scale. And what does it mean? Talking about 100% uptime. A lot of time talking about relational databases, a lot of companies are running into scalability problems. Why? Because relational databases, they have vertical scale,
scaling, yeah.
horizontal, yes. And what does it mean? You will need to burst the power or the size of a machine that usually end up in tremendous amount of money to pay. And a lot of times, once that machine just runs out of capacity to serve your application, you're just going to end up having the outages. Cassandra has been built in architecture, and we're going to just look at in our next slides. I will show you why and how Cassandra allows us 100% uptime. Zero lock-in means that Cassandra is being open source. You can run it on premise or any cloud of your choice, which a lot of times that's huge privilege when you're building this real-time application. So you don't need to pick one cloud to another. So you can build in one and then expand and leverage Cassandra resources as you grow as an enterprise. And global scale with Cassandra, you can leverage any regions of your choice to provide real-time access and the minimum latency to your real-time application.
Makes sense.
So we talked about a lot of theory, such as how amazing Cassandra is. So let's step in and see how Cassandra works in practice. So here we put some examples of relational design database. And what we've been referencing early, just even considering the employee and department state, usually in a relational database, you have unique key, how you've been like merging or joining the other tables to get the output from normalized data sets. And as we also determined, that usually takes a lot of memory, a lot of space, disk to store, time that results to make all these points and joins. And talking about time, if anyone who watching right now this video who's writing SQL in terms of a big data, they know how much time it usually takes to process all this multiple tables, big data merge. Talking about Cassandra, this is the point where Cassandra brings the power, such as we cannot think anymore taking the same data model approach, what we have in relational database. The approach have to be different. And that approach, what we were talking about, have the queries in mind or the value what your real-time application need to bring. That is how we want to build our tables. As this is example, let's say building application that need to retrieve in real time the employees by car make. And as a result, we are storing or partitioning our data based on the car manufacturer. And you may ask why to care about it? And the reason for that, every time when application will connect to our database trying to retrieve the data, we want to allow that application, a logical tier of application, to retrieve all the producers of the car from the same type to be analyzed, categorized, maybe sort and retrieve back to the application from that. And that is the only, at least what I'm aware of, data model that can allow to do so.
Yeah. So like if I could just reiterate that a bit, if we the use case which we are taking here, of course, how should we design NoSQL databases or the whole database design, that has to be done in a separate video in quite detail, which we'll do in future. But here, if we take at this example, here we are saying that let's say our application has to list employees which have a certain car type, right? Or which have a certain car make. So that's the type of requirement which we have. Now, if we go with the older approach, as was shown in the last slide, you will probably join two tables and then get out that you'll be able to take out that data. Whereas here, because this is a known query pattern, we are able to define the table itself in such a way that this particular data, which is basically the car and the employee information, is available in one table itself. That's first point. And second point is it has been structured in such a way that, as Kseniia has explained, you will be able to query based on the car make. That's why you see the make column is there as the first one, and you'll be able to query against that. Yep.
And if for some reason, whoever is watching us today, you're experiencing the scalability issues coming from relational database world. And by the way, I'm not saying that relational databases are bad. They're amazing, but not quite real-time applications, yes. And if you need to build your real-time application and you happen to have a lot of data models that are being built on relational database set, there are tools available and some professional services that, like if you're talking to enterprises, that can help to move from one to another. And talking about this distribution, and we also distribution of data and this high velocity point to retrieve data, and talking about the global scalability and being available, how Cassandra allows to do so. So there is architecture behind the database. And what does it mean? What do you see here? Usually when Cassandra architecture being explained, they always bring this circle or cluster. What does cluster represent? A cluster have nodes, and you can see the numbers 0, 17, and so on, so on, so on. So these nodes, you can see them as the minor sets of databases. And each set of this minor database, they most likely may be related on different region or different geolocation, or maybe they've been meant to store certain set of data for, let's say, talking about the car manufacturers. In one node, we can store all our BMWs, another node, we can store all our Audi references. So every time an application calls with a certain request, let's say BMW queries that we need to process really fast and real time, the Cassandra will know based on partition key, which is BMW, which node to refer. And as a result, instead of having one giant machine to store all your tables in one, we can distribute and relocate those nodes in different machines that can be scalable on demand based on the data you're putting or retrieving from that. And that Cassandra is being open source built. That circle kind of approach allows a high availability by itself. So there is a term known in Cassandra architecture as replication factor, and usually it's been recommended to use number 3 as replication factor. What does it mean? Such as all the data located on 0, it being replicated to nearby closed nodes. So what does it give you as a developer or maybe business owner? Once your one node can, fail over for different reasons, you have others to take on the load without setting up the connections between or worrying about that your application won't be available. That is the point, one of the points why when we brought up the definition of Cassandra, that is something that allows 100 uptime of application run because of its built-in high availability structure.
Right. The replication factor, I think that's a very important point which you mentioned. Surely for a production setup, as you said, we should keep it at least 3 so that there will be that many copies of the data stored, and that too in different nodes, or we can say at different physical location. So even if one physical location is out because of some reason, we are not losing the data, and automatically Cassandra would be able to serve or give the data back from the other location, and we don't need to really worry about it, right?
Right, 100%. And that is why when we reference that slide for who's using Cassandra today, that is one of the reasons, because companies not only can build real-time applications, they also have guarantee that that database provides the resiliency and going to be up to date when it's going to be needed. And here just is a bit of visual aspect to tie the table when we were referencing the car maker and the employee name. And again, taking this circular architecture of Cassandra, that is how data is going to be distributed among the nodes. And obviously, you're the developer, you have an option to first define your data model, second, define how you want to store. Here we just give you example, again, on the sake of building this application that need to retrieve the data maker with the owners using first name, last name in the fast capacity. But obviously that use case really might vary based on application you're building. But that access or that distribution allows us, when someone from front-end application comes and need to retrieve all the BMW owners, we can just give a BMW as a partition key, and the Cassandra will return us all the people who owns it. And one other interesting aspect of the power of Cassandra, what we mentioned, that is being columnar database that allows to set many columns to get the data that query will need to serve the front-end application. What is else is the differentiator point related to NoSQL Cassandra versus, let's say, relational database. In a relational database, the table is set. I would say almost, maybe some NoSQL SQL databases have the capacity to bring a new column, which I don't know, I'm not aware of. If you do, please share the knowledge with us. I would like to learn from you. But what I've seen Cassandra being really used when, let's say, you build the application, you only know, let's say, today your queries, and tomorrow you might have additional usability of this application. What to do? Do you need to change all your tables to match your application need, or maybe you just need to add another column? And even more, as a Cassandra being columnar database, you can sort by the column too. So it gives you a lot of flexibility and power to add the data and retrieve it and work with different data types.
Yeah, you are right. In case of relational databases, typically the schema design would be fixed. Once you create the table, you do not, I mean, it's not that it's not technically possible to add a column, but it might break many things, and it is not that easy really, that it is kind of that you just go ahead and change columns and you don't need to tell anyone. It doesn't work that way. Whereas something like Cassandra, it has got this like non-fixed or dynamic schema, so that maybe in the same table currently you have X number of columns, tomorrow you may have more columns. It's perfectly fine. There's no problem. That's really good one. Yeah.
And here's a couple examples again that can be speaking of the value of real-time applications. So I'm sure some of them really familiar to you: Verizon, Macy's. Macy's is a retail store. Verizon is the biggest, at least in the United States, the telecom provider. Titanium Intelligence Solutions, they're building IoT as a platform, such as in IoT world, we have millions of data written to the databases, and there should be some database to be at least scalable enough and resilient enough to store all of this. You may ask, okay, I see a real use case of Cassandra. Here's the use cases. What is the meaning behind of that slide? And the meaning behind all this, where we started this speak or story, we mentioned that Cassandra is a really powerful tool. But giving you this example and use cases, I want you to be mindful, be aware that Cassandra is a powerful tool for really big writes and relatively fast read requests. So in other words, like Cassandra, if you want to remember anything from this talk, Cassandra meant to be used in a real big data, bulk loads, bulk write requests. And here's those examples as a sensor data messaging system, e-commerce website, fraud detection. It just meant, or the nature of these business lines, they deal with a huge amount of data and real time that need to be processed to bring the value to the users. Imagine you log into the Macy's website or application and you just keep waiting for the shopping list to be updated. Or maybe you happen to shop something that Macy's not even more having at the stores. So that will result in your end user or customer dissatisfaction. And as a result, Macy's will probably end up without, the additional revenue and so on. So again, be mindful. Cassandra is a really great tool, but it also needs to be used with caution for specific use cases.
In order to understand, sometimes unless you have seen the use case for somebody new, it might be a bit hard to imagine that what are really those use cases where where that much amount of data or that fast read requirements will be there. You'll have to think about the scale of the businesses, right? So something like an example which Kseniia took in the start, something like Starbucks. If you look at Starbucks and try to sit and imagine the scale at which they operate, right? The number of stores, and then on every store, the number of people who are buying, and just think about their IT systems, then it will give you some idea that at what rate that whole read, write, etc. is going to happen. Of course, if we just think about a simple small application, it might not make a lot of sense. It is perfectly fine. You can make it work even with relational database or with anything else. Because you will not have such challenges. So when it really comes to achieving that scale, and for such big businesses, NoSQL databases help, and that's where, of course, Cassandra comes into picture. Just want to give that perspective. Yeah, go ahead.
That is amazing. With that side note, you're actually helping me to jump in another note of what is DataStax and where the company where I'm today, what the value it brings. Absolutely agree with you that with a lot of power, a lot of responsibilities usually come. And even though Cassandra been giving a lot of amazing features and benefits to the value out of the batch, it is in reality really hard to manage and scale on demand. And that is one of the reasons how DataStax came out and how they even identify the need to build this company's DataStax. So here's a little bit of the short story that Facebook, and you probably know, maybe even use it daily as application. At some point, they figure out there's no database that can serve the load and amount of on a global distribution to provide the real-time services for the end applications or end users. And that's where Facebook chose to build their own database, NoSQL databases, Cassandra. And in 2008, Apache Foundation adopted that tool and made it available to the whole world as open source. Around 2010, DataStax figure out that even though Cassandra brings a lot of power, but it also brings a lot of headache to operation team. It brings some certain roadblocks to provide multiple regions and so on, so on. And as a result, DataStax came out with the products that we're going to talk shortly. And our mission as DataStax, we serve real-time application with OpenStack that just work. And real-time application, we already defined that term, such as applications that need to have the real input, the real results, the real time value that is needed. And what does OpenStack mean? Is OpenStack we're not only providing database as a service that we're going to talk shortly, but we also provide the solution for the whole database ecosystem management. That just works. And here's the proposition of Astra database. What we talked so far about the power of Cassandra. Astra database multiplies that power by providing the power of Cassandra on a level of services. So if you heard software as a service, when you don't need to deploy, you don't need to manage it, so you can just log in using your SSO, your email, and start using the power of Cassandra without figuring out how you're distributing these nodes, how you provision it, how you need to even provision the database with the most updated security patterns on any of the cloud. And I know you're working with a lot of AWS resources. You're probably even aware more in production level, how hard it's to manage production level application to be in the most secure way, right?
Yeah. So I would like to just add here. See, it's perfectly possible that one can go ahead and just pick up Cassandra. It's available for anyone to go ahead and use free of cost. You can go ahead and pick it up and just deploy it for your production use case. But then, as an organization, you will have to spend considerable effort in setting it up, in maintaining it, patching it, making sure that interaction of Cassandra as a software with the underlying infrastructure, like whenever something goes wrong, or something has to be some scaling needs to be done, you need to be involved to a certain level for sure. And depending on the complexity of your organization and your operations, it may increase or decrease, right? Now, I think going with a managed solution like Astra DB, what we are seeing here, you don't have to get into any of those operations. You just go ahead, get started, and start using Cassandra, and leave all the management overhead to this organization. That's what we are saying. Yeah.
And Mayank, to your early point, when you were talking about the use cases of Cassandra, you brought up the point that it's really important to think of long-term games, such as scale, how much real-time application need to grow. And that is absolutely true with open source Cassandra. But the power of Astra DB, or the values that they propose, the individual can start as small where they are, because they don't need to think about the hardware. They don't need to think about the complexity and operational side of Cassandra to use the power of it. So in other words,
like a person or an organization can just focus on building the features in their application. The whole DB part just works out of the box, with the Cassandra power. They don't have to really worry about it, I guess.
Yeah, and to that point, what you just brought up, bringing a little bit of overlay the power of Astra database, and I will start from managed database. Again, just forget about managing AWS, Azure, or Google resources by your own self. We provide the infrastructure where you just, with a one click and just giving the name for the database, you can provision one. And talking about being cloud native, DataStax, they managed to bring the power of Cassandra and serverless on microservice level architecture. What that means for the end user, that just recently I just came back from Grace Hopper conference in Orlando, and I talked to a developer from Gap. It's retail, like really multinational retail store, and the developer was speaking of Cassandra, and the way he described Cassandra, he said, well, Cassandra, when its work is perfect, it's like provides and work as supposed to. But the problem is when maybe too many writes come, and when the Cassandra doesn't work in optimized way, it breaks. So that is why DataStax came up with architecture leveraging a microservice approach, so the end user will get the most benefit on optimized database work. It optimized on the level of writes and reads, so it doesn't matter how many writes you have, it will be powered to have enough, like in milliseconds, read requests based on application needs. And talking about the flexibility side, imagine if you're a developer, what is the use of database when it's not connected to anything, right? And some databases is really hard to bring the connectivity into the application, maybe connectivity to machine learning or analytical world. And with Astra database, DataStax builds a vast variety of the tools or layers to communicate with database. It might be REST APIs, document APIs, SDKs. It might be like if you're building Java drivers that need to be connected to your front-end application, maybe using the more newer stack as React. So all these connectivities and integration points being built in Astra database as soon as you provision the database.
Right. Good. If I may just request, if you go to the previous slide, sorry. So I think on this point, I'll just pick up. If an organization wants to use Astra DB, then they don't need to really get into AWS, Azure, or Google Cloud Console. They can just do it right from Astra DB console, and they can, span their database across multiple clouds if they want. Is that correct?
And I'm going to, at the end of a presentation that we're going to reach, I'm going to show you how this platform as Astra DB looks like. And I really want to share with you, whoever watching that presentation, that Astra database, even though it's a commercial tool meant for enterprises, DataStax made Astra DB available for users who want just, first of all, who want to learn, who want to try. And once you log in, DataStax gives you $25. I know it might not seem a lot, but believe me, and I've seen even today some of the startups using Astra database for free, so they don't paying any commissions to DataStax, and they're able to leverage all this capacity and value to build the application real time for the real users.
So this $25 is like per month. Every month the user just can use it for $25 worth. And that's really good one, I think, for people to get started. If you are really interested in it, you can just go ahead, get started. You don't need to get into any contract or anything like that, I guess, and you can just make use of it for free every month.
Yes. Right? So if you're managing, if you're coming ready with Cassandra knowledge and somehow you get tired of operations and building those handmade, homegrown integrations, that might be a little bit easier solution for free to use.
Right.
And here's a little bit of example of the replication, such as having an application running on a single region. That what Cassandra open source offers. We can bring the ability of Astra database and spin up the data centers on the regions what we need. So here on the top, we just briefly run through how the application replicates the data among different data centers. And here I just got a snippet from the Astra database platform. And I just wanted to give you the example of the difference. When you build that infrastructure yourself using open source, imagine it takes a lot of pull from engineering team, application developer team, and it takes a lot of at least knowledge of the clouds to make it happen, and more work and time and cost to be involved. And what I'll show you later at the end of this demo presentation, how you can just spin up a new additional region on your demand without knowing any cloud infrastructure behind it.
I would like to add this thing. One of the things which I really like when it comes to managed services is that organizations have done a lot of engineering and they're making it available to you so that you can go ahead and use it either for free or for a very small cost. Now, whatever is shown just now on the screen, if an organization plans to get this thing done by keeping few engineers, it will take good amount of time. And whether we will be successful in the first shot, we don't know. It might happen that after a couple of weeks of work, people say, let's try it, and it did not work. Now we will we will try it once again. But here, this part is done. If anybody is interested, in next 30 minutes, person can go ahead, get started with it, actually experiment and see that whether this thing really works, right? Or not. A person can go ahead and see it on their own and really quick and without, involving a very big team for that matter.
Yeah. And Mayank, to that point, what you brought up about managed services, I know today you're helping people to be more versed and more professional on AWS services. That's right?
Yep.
And imagine if our viewer who are watching this video will take for granted AWS services that have been provided and try to build your own machines on demand, how you need to use it. So that is, I guess, one of the powers of AWS, when you can just come in and just forget about all this infrastructure, details in terms of the hardware. So you can use AWS and the power of the services when and how you need to use them.
Yeah. So yeah, I think that's the whole point. The reason why I started saying that is because many of the places I have seen that organizations or certain organizations, they still try to keep the whole management with them, right? So on one hand, yes, you are going ahead and using one of the best technologies which are available, open source, some of the best minds build it, it works great. But then because you are keeping the whole management with you, you introduce all those manual errors in its operations, right? So I'm not saying that go ahead and just trust anyone blindly. Go ahead and test it at least. Go ahead and test it and see. There are organizations who are giving some good managed service, and that product is being used by many of the real big businesses around the world. So any other organization which is thinking of managing the whole thing on their own, compared to that, it's a lot better that go ahead and start using a managed service. It can reduce your cost a lot and also improve the service quality to a good level.
And there's going to be the last kind of theoretical approach or overview of DataStax and the value it brings. Today, we only spoke about like database side, and that is where the power of Cassandra or database as a service as Astra database comes. That is a kind of usually at the core. Again, I want to bring you to our the first slide of considering this iceberg analogy. When the companies or enterprises, businesses need to bring the power of BI analytics and real-time application use, they need to consider at least and start from the first ground as what database they use for that cause. And one of the power of Astra database, it comes that is platform agnostic. It can be used for high velocity transactional data type and give it flexibility of different data type to be stored. But it's not all it, like it's not the end of the story. The DataStax bring capacity to bring integrations as bringing, let's say, Astra streaming capability to that database that you might already using, such as it can capture all the flows or changes in your like one side of data management flow, or maybe if you need to do data captures from your front-end applications or other resources. So those capabilities to integrate your database in your already existing infrastructure is possible with DataStax. I know if, let's say, if you're coming as recent graduates or have never worked with databases, that slide might possibly throw you off because a lot of details. But I guess the biggest gist to take from it is that in order to drive prediction analytics, database just itself is not enough. Someone need to consider and bring the database solution as cohesive, pipeline to bring that the right analytics, the right dashboards, let's say as company Snowflake or BigQuery provides. But the right fundamental as the right NoSQL database is meant to build real-time applications.
Correct. Yeah. Of course, I think for any successful or good application, it becomes very important that the application part has to be thought through in in a really detailed manner. Of course, the tools which we are using, they are also equally important. So we have to use each and every tool which is supporting that application, that has to be of good quality. But then what do we want to achieve? Business SMEs need to define that, and that then should get translated into the technical objectives which the team achieves. Many of the places, if there is a disconnect in this anywhere, the project goes for a toss. Right. Okay. So here we are looking at the console. Yeah. Go ahead.
And we brought up one of the organizations. And by the way, anyone who's interested to use Astra right away, and it's power, you can just log in using your personal email. And here, one of the databases already been previously provisioned, and that database empowers this front-end application for, let's say, device stores. And here we see the description of the device, the image, and that's being pulled out from database, which being any database can be created on the Power, just giving the name, the key space, and right here you have the choice which cloud.
Okay, so I was just saying that you can see here that there are multiple regions available. So you can select, while you're provisioning the database, you can select multiple cloud regions as well. And this ties back to what was shown on the slides earlier, that depending on the reliability requirements, you can have your data spanning across multiple cloud regions as well. And that kind of saves you from a really bad day when a complete region itself has gone out.
And on top of that, once the database has been provisioned and the connectivities that we've been using to build this React application is been given to us out of the batch, as simple as just copying the provided snippet of code, we could build our Node.js application. And that is it, the end of my sharing on knowledge I wanted to give. And it was a huge pleasure from my side.
Thank you, Kseniia. I think it was good. The intention of this particular session was to give an introduction really about Cassandra as a product, and then after that, if you want to use it, if you want to get started with Cassandra, how you can go ahead and make use of Astra DB for free. You don't have to really spend any money. Just go ahead, get started, try to play with it and see what are the capabilities available. We will also try to bring more videos in this series. If you are interested, we can, there are a few ideas. Probably we can pick up some examples and do DB design for a given scenario. So if you are interested in watching those, please comment and let us know, and we can plan for that for sure in future.
Thank you. Bye. Leave us some comments if you have any further questions.
Sure. Please let us know. And one more thing, I will also leave all the relevant links in the description, which you can follow if you want to learn more about Cassandra, the right pointers for different tutorials or documentation. I'll leave it in the description so you can go ahead and check it out. All right. Thank you, everyone.
Bye-bye.